So welcome students. So in this question, you're given the differential equation x times dy by dx is equal to y times log y minus log x plus 1. You're asked to find the solution of this. So by observation, you can see that this differential equation is made up of terms like y by x, because we convert this differential equation x times, so if I bring this x onto this side, you get dy by dx is equal to y by x times log y minus log x can be written as log of y by x plus 1, right? So you have y by x here, y by x here. So this is of the type homogeneous, where we substitute y is equal to vx. Whenever you have differential equation majorly made of y by x's, we substitute y is equal to vx. So this implies dy by dx is equal to v plus v into dx by dx is 1 plus x into dv by dx. v plus x dv by dx. So dy by dx is this. So if I substitute this here, so v plus x dv by dx is equal to y by x is nothing but v times log v plus 1. That is v log v plus v. If I multiply this v and this v is getting cancelled. This implies x times dv by dx is equal to v log v. Now let us update the variables. So you get dv by v log v is equal to dx by x, right? dx by x. Now once the variables got separated, I'll integrate this. So what is the integration of this? You have log v here and the differentiation of this here. So if I assume log v as t, dv by v becomes dt. So this is of the form dt by t. dt by t. So what is the integration of dt by t? Log t. It is log of log v is equal to log of x plus c. Log of log v is equal to log x plus c. So this is the solution of this differential equation. If I uniformly apply e power on all the sides, or I can assume instead of c, I can assume it as log c, right? And this implies log v is equal to log of log v is equal to log of x into c. Log x plus log c is log of cx. So log of log v is equal to log of cx. So log v is equal to cx. Now once you have the solution, let us just put y is equal to vx or v is equal to y by x. So log of y by x is equal to cx. That will be the solution to this differential equation. Thank you.